The recent advancements in technology is leading the human race to many new frontiers. One such example is the quest to harvest energy in space from our galaxy's biggest energy source, the Sun. While harvesting the solar electricity is quite straightforward, transporting it to Earth from space is a different thing altogether. Stay with us till the end as we tell you how we can transfer the energy from space back down to Earth. The beginning of SBSP. The concept of SBSP, or space-based solar power, has been attracting lots of attention all around the globe as a potential answer to the world's energy problems. All of this started way back in 1999 when NASA started its mission to produce electrical power by converting solar energy under the name of Space Solar Power Exploratory Research and Technology Program, also known as SSERT. SSERT set about designing a solar power satellite concept for a future gigawatt space power system. It also presented a conceptual development route that would make use of current technologies. Not only this, SSERT also developed an inflatable photovoltaic gossamer structure with solar heat engines or concentrator lenses to turn sunlight into energy. Moreover, the program also looked at the geosynchronous and sun-synchronous orbits system in detail. Space energy and its benefits. The fundamental idea behind producing electricity from space is to collect solar energy from the sun using satellites or other spacecraft and then return that energy to Earth. This energy can then subsequently be transformed into useful electricity and sent to the planet's power grids. The fundamental benefit of SBSP is that it provides a steady supply of energy that is unrestricted by seasonal variations or the time of day. This way, even the most isolated or hostile areas of the world can get a stable source of energy from satellites, which can continuously capture solar energy without interference from clouds or other environmental conditions. Not only this, but as they would be above the Earth's atmosphere, the satellites would be able to collect more solar energy than ground-based solar panels, which are constrained by things like cloud cover and the sun's angle. However, amidst all the benefits of SBSP, the problem of getting this seemingly endless energy from space to Earth is its largest obstacle. Wireless method. There are numerous viable approaches to tackle this major obstacle of SBSP, each with advantages and disadvantages of their own. The most promising technologies for wirelessly sending power over a large distance from an orbiting satellite to the Earth's surface right now are laser beam and microwave power transmission systems. Both transmission modes are safe for people, animals, and plants, as the laser beams in the suggested designs will function at wavelengths that are safe for skin and eyes with an intensity comparable to regular sun exposure, while the microwave radiation will have an intensity that is roughly 1/6 that of midday sunlight. Now, let's look at how these systems will actually work. A laser beam transmits focused light to a photovoltaic cell receiver in the laser beam wireless power transfer method through the vacuum of space and the atmosphere. The energy is then transformed back into electricity by the photovoltaic receiver, which works in a similar way to solar power harvesting that turns sunlight into energy when it hits solar cells. The efficiency of this approach is higher than that of solar cells currently available because it makes use of high-intensity laser beams on specialized voltaic cells. Interestingly enough, this method enables the controllers to target any receiver with a clear line-of-sight transmission channel right beneath the satellite by the laser beam using mirrors and telescopes. It is worth mentioning that there are benefits and drawbacks to both the microwave-based and laser-based wireless power transmission techniques. That is the reason why many researchers often suggest a hybrid strategy to create the best system. In such a system, a laser would be used to transport energy from a solar array to a base station in space. The base station would transform the laser's energy into electricity, which would then be delivered to the receiving station on Earth as microwave radiation. As a result, the laser beam is employed in areas with little atmospheric attention before transmission switches to microwave radiation, which is far less affected by atmospheric attention. According to calculations, this method has the potential to be very effective, transmitting energy at a rate of up to 10 gigawatts per beam. It also calls into question the security of directing powerful electromagnetic radiation at the ground, as well as the possibility of interference from the weather or other elements. Some academics have suggested deploying a network of small, low power beams rather than a single high power beam to allay these worries. Additionally, the risk of radiation exposure would be lower with this method, which would also be more resistant to interference from the weather or other variables. The Japanese Aerospace Exploration Agency is showing massive interest in this, and along with NASA, they want to develop a working commercial space solar power system. The cable to space. Another way to send electricity from space to Earth is by using a physical connection, like a cable. This requires building a huge cable that extends from the satellite to the ground, where the electricity would be transformed into usable form. While employing electromagnetic radiation no longer has some safety concerns, this method calls into question whether it is possible to construct such a long connection. While many are in support of this, some researchers have suggested employing a space elevator rather than a cable. Theoretically, a space elevator would extend from the surface of the Earth into space with a counterweight at the other end to maintain the cable's tension. After that, a spacecraft would ascend the cable to the satellite in order to collect solar energy before descending the cable once more to reach Earth. While still at the theoretical stage, this method presents a fascinating opportunity for transferring energy from space to Earth without the use of a huge cable. While both these processes could work, the utilization of a hybrid system which combines the advantages of both physical connection and microwave transmission is also a possible strategy. This would entail sending electricity by cable from the satellite to a platform at a high altitude, such as a blimp or a drone, which would then beam the energy down to the ground. While reducing some of the safety risks associated with direct microwave transmission, this strategy might offer a more dependable and effective system. The obstacles. However, no matter what strategy is employed, there are a number of significant obstacles that must be overcome for SBSP to become a reality. Firstly, the maintenance will be very difficult, as it is quite clear that an Earth-based solar panel can be maintained rather easily, while a solar panel in space would normally be built and maintained telerobotically. In addition to being more expensive, PV panels degrade around 8 times faster in space than they would on Earth due to the harsh environment. Furthermore, space debris poses a serious threat to big objects in orbit, especially for big structures like SBSP systems traveling through the trash below 2,000 kilometers. Even though the price of space launches has decreased recently, the expense of creating and launching the required satellites or other spacecraft is still a very big obstacle for many organizations. There are also worries about how many satellites being launched into space would affect the environment, as there is already a serious issue with space junk. The future. Over the past 20 years, the cost of solar energy as a whole has been falling more quickly than most industry participants anticipated. So much so that solar energy is currently the least expensive way to produce electricity in the Middle East and Australia. This will also hold true in the nations of the mid-latitudes as technology advances. According to estimates, the EU will use solar energy for more than 40% of its energy by 2050. As a result, solar energy would become the EU's main source of energy. All in all, as the technology develops, space-based solar energy may be a potential answer to the world's energy problems. We might be able to supply a consistent, dependable source of energy that could aid in sustaining our globe for a number of generations. That is it from today's video. We hope you enjoyed the content of the video. If you did, show us some love and hit that like button, and don't forget to subscribe to our channel so you will never miss out on any of the amazing videos we have in store for you.